In the previous videos, you learned how Google's PageRank is computed. It is clear that the PageRank value is very important since it determines how easy it is to find a page. Unfortunately, this has also led to people think of how to artificially increase the PageRank, basically by making use of assumptions made in the PageRank model. Artificially increasing the PageRank number of a page is called link spamming. We will not explain how to do this in detail, but instead give the main ideas using a very simple graph. All techniques amount to creating loops in the graph. Without teleportation, the random surfer would be trapped in a loop, and once the surfer enters, he cannot get out. He would keep visiting the same web pages within the loop, and as a result, these pages get a very high PageRank. As an example, we take the small network that we used in the other videos. On the left, you see a graph, and on the right, the PageRanks of the web pages in the graph. This is for the standard Google model, so teleportation has been taken into account. Clearly, web pages 1 and 2 score highest. We are going to link spam page 4 by changing some of the links, and will show that the effect of the PageRank of these changes. The first step is that we change the dangling node 7 into a node with an inlink and an outlink. We also remove the inlink from page 3. As you can see, page 4 now has 3 inlinks and only 1 outlink. This outlink leads to page 7, which only has an outlink back to page 4. Until teleportation occurs, the random surfer will keep going from back and forth between pages 7 and 4. This results in a much higher PageRank for page 4 after the modifications. In fact, page 4 is now the page with the highest PageRank. This simple example illustrates how you can manipulate the PageRank. Much research has been done how to detect and suppress such link spamming. It turns out that the link spamming can be detected using an eigenvector for the second largest eigenvalue of the Google matrix A. This has quite intriguing subject, but unfortunately goes beyond the introductory lesson. This concludes our introduction of how the PageRank algorithm works. It is a nice example of how to determine the relative importance of nodes in a graph. Many big data problems have such a structure. The ideas discussed in these lessons are therefore also used for ranking other problems than internet pages. Think, for example, of the ranking of the importance of scientific papers. The list of other applications is very long.